Okay, peeps, here we are. We are looking at page 40. Here we go. We've seen this now. To take a determinant, they call it a second order because it's a 2x2, of a matrix in this form, this is how they're going to ask. Go find the determinant of this matrix. Do you agree that these little bars here look different than these bars here? These ones almost look like absolute value bars. And when it's written as absolute value bars, they don't have to ask for the determinant. When it's written like that, you have to know to get the determinant. So that's why on this one, when it's got the little bracket, if you will, it'll say, find the determinant, DET, of this. Or if it's written like this, we just have to know. Go do black diagonal minus red diagonal. Let's do it. Let's do that right here. What would be black diagonal minus red diagonal here? Oops. Black minus red. 48 minus 24, 28 equals 20. That's my determinant. So now, look at this real fast. Look at this. Does this kind of make sense? Look at where this A, B, and C came from. Boom, boom, and boom. What did they do to B's sign? They changed it, didn't they? So just make yourself a little note. Maybe like always opposite sign, something like that, so that we don't forget that, because that's real easy to do. And now let's practice it. We know how to do this. We're going to bring that A out front. What was our A in this case? Yeah. A is -4. I'm going to bring that out front. And what would be the 2x2 that's left? I'm left with that, right? -1, 3, 4, -3. What do I want to put? +6 or -6 next? +6. Good job, you guys. I'm going to do +6. My 2x2 would be a 5, 3, -2, -3. And then finally, my C term will be back to normal, +2, left with 5, 3, -2, -3. I'm going to bring down my -4. We've got to do black diagonal minus red diagonal. So we'd have, yeah, we'll get an actual value on this. 3 minus 12.
For the last one, it'd be 5, -1, -2, 4.
Sure would be. Thank you, Steffi. She's saying get this part right. My goodness. You just saved me. Thanks, Steph. And I want you to double check how are your numbers comparing to mine, because I just made a mistake. So make sure that I'm not crazy.
I give you 22 because it's 2. Oh, wait, no, you're right. Sorry.
That one's a confusing one. I agree. Eh? 5 times what is going to get me 5? 5 times 1. And then this is called the multiplicative identity. And so 1, any number times 1 always gets you that number. And I'm here to tell you that this is the identity for a matrix. This represents the number 1 in a matrix, okay? So meaning if you multiply any matrix times this, you should get what you started with, because this really represents the number 1. Let's practice our multiplying process like we practiced yesterday. Oh, first of all, does anyone know what these cute little 3 dots mean? Aren't they so cute? They're on there for a reason, and they're over here too. They mean therefore. And I didn't really start using those till like college math classes, but if you have to take some higher level math classes with like some proofs, it's saying if this is the identity, therefore, a matrix times 1 should get you that original matrix. And the dot goes boop, boop, boop. It's just like a little triangle. But even in college, I would just do I wouldn't even make them circles. That takes too much time. You're going to do this a lot if you take higher level math classes. So just want to throw that in there. Okay, let's practice seeing what we would get if we multiply these, you guys. What shape is this cute little cutie? A what by what? 2 by 2. How about the next one? Can we multiply them? My answer would be a 2 by 2. So I'm going to get my answer ready. And I should get what I started with. I should get A, B, C, D. But we're going to make sure that we do. All right, when we multiply, you guys, this is practicing yesterday. This spot here is in the top row left column. So that top spot there is top row times left column. What am I going to get when I multiply A times 1? A plus B times 0 is 0. So A plus 0 is A. That gets me this. I should be getting what I started with, so far so good. This spot is top row right column. I got to take top row times the right column. What's A times 0 going to get me? 0 plus B is, phew. This is all working out here. Bottom row left column, this spot is bottom row left column. Let's multiply it. C times 1. C plus 0 is still C. I'm feeling really good. We got bottom row right column. Bottom row right column, I'd get 0 plus D is D. So that was me just helping you prove, oh, this matrix really does represent 1. So anything times 1 should get you what you started with. Lastly, if this is an identity, 1/8 times what would get me, what am I looking for here? 1/8, the multiplicative inverse of 1/8 is, a multiplicative inverse is just 1/8 times 8 is going to get you how much? Yeah. So again, multiplicative inverses is what can I multiply by to just cancel each other out and get 1, and it's 1/8. In order to find the inverse of a matrix, check this out, people, check this out. The inverse, another way to say inverse is something to the -1 power. Holy smokes, look at what we got to do. We're going to practice these, we're going to practice this problem, and then we'll call it a day. We're going to practice this, we're going to do this and this, and we're good at. To find an inverse, you could do 1 over the determinant. One more time, the determinant is just A times D minus B times C. We got to do 1 over the determinant, and then look what they do. They move things all around. And this gets us the inverse. What? Who cares? Am I right, people? But we're going to do it. Here we go. Let's go just break this apart. Let's first start with finding the determinant. The determinant, one more time, is just black diagonal minus red diagonal. Let's go find the determinant of this one. It'd be 8 minus -12, so 8 plus 12. Final answer, 20. Our determinant is 20. So you guys, our determinant right here is 20. So we're going to say 1 over 20, and I'm getting that from right here. So let's go ahead and write inverse equals 1 over 20 times, and we're setting up for this matrix. Put myself a little bracket. What they want us to do. We are always given a matrix in this form, A, B, C, D. Look at what they want us to do. My D and my A have to switch spots. So my D and my A here got to switch spots. So it was 2, 4. I'm going to write it as 4, then 2. Then look what they have us do. Do my B and C move? No, but they just both, their sign has to change. Their signs have to change. B and C's sign have to change. B here would turn into a 3, agreed, and then this C here would turn into a -4. Guys, we're getting there. We're getting there. So this is the setup of the inverse. We now need to take 1/20th times this matrix, and that's going to get us our answer. What is 1/20th times 4? Simplify it. 1/20th times 4 would be 4/20ths, which would get me 1/5. Boom. What about 1/20th times 3? It's just 3/20ths. We can't simplify it. Very good, Miss Steph. What about 1/20th times -4? -1/5. And finally, you guys, what's 1/20th times 2? 1/10. You guys just found the inverse. Whoa, that was a lot. You just found the inverse. And you're like, okay, great. Don't care. I hear you, people. Here's the deal. Here's the last thing we got to do. In order to prove that we found the inverse, we got to take the original matrix. We got to multiply it by that inverse, and we better get this. If we get this, we know we did it right. Whew. Last thing on this Friday, here we go, people. We got to take the original A, which was 2, -3, 4, 4. We need to multiply that by the inverse, which is 1/5, 3/20, -1/5, 1/10. And we're hoping we get 1001. Can we multiply this 2 by 2 with 2 by 2? Yeah, and my answer is going to be a 2 by 2. I always like making my little answer spots to help me multiply because multiplying is tough. Okay, this spot up here is top row, left column. Let's take this top row times this left column. You guys, we're going to be intimidated, but we can do this. We can do this. We can do this. What do you think 2 times 1/5 will get us? Let's try it just out loud as opposed to in our calculator because we can do this. 2 times 1/5, 2/5. Okay, so we get a 2/5 plus, what about -3 times -1/5? Yeah. What do you think 2/5 plus 3/5 is going to get me? 5/5. I love how you said that. 5/5 is the same as 1, Steph. Boom. We're supposed to get 1001, so I feel like that's a good start. This spot here is top row, right column. Top row, right column. Ew, this one's kind of gross. Here we go. This would get me 6/20. Awesome. 6/20 would be the same as 3. 6/20 would be the same as 3/10, right? Okay, so we got a 3/10 here. I'm just going to write it off to the side so we got it. 3/10. And then guess what? Plus, what's this one going to get me? Hey, Parker, 3/10 minus 3/10, isn't that getting us 0? And we wanted that. We BM, Parker. You guys, we want another 0 here. This is bottom row, left column. Bottom row, left column. Boom. What's this getting me? 4/5 plus a -4/5, so just -4/5 gets me. Boom. This is feeling great. Last but not least, people, this spot is in the bottom row, right column. Bottom row, right column. Boom. What would that get me if I multiply it? 12/20 is 6/10. That would give me 6/10 plus, what's this going to get me? 4 times a 10th. 4/10. What do you think 6/10 plus 4/10 is? 10/10, which is 1. We did it. That means that we got the right answer. Holy smokes.